Hello everyone. Now we'll discuss about what is linear convolution and how it can be computed. Linear convolution is the mathematical tool used in the digital signal processing in order to compute the output of the system when input and impulse response of the system is known. The linear convolution can be computed in three ways. One is using tabular method, which uses the formula for the computation of linear convolution. Second method is graphical method. Third one is matrix method. In first method, the linear convolution of the sequence can be computed by using the formula y of n equal to summation k equal to minus infinity to plus infinity x of k h of n minus k, where y of n is the output of the system, where x of k is the input, and h of n minus k is the shifted version of the impulse response. The length of the output actually depends on the length of the input sequence and length of the impulse response sequence. The length of the output sequence y of n equal to L plus m minus 1, where L is the length of the input sequence, m is the length of the impulse response. Now we will see one example problem for the computation of linear convolution. The given samples are x of n equal to 1, 2, 3, 1 and h of n equal to 1, 1, 1, and this can be computed by using the formula y of n equal to summation k equal to minus infinity to plus infinity x of k h of n minus k. Here the length of the input sequence is 4 and the length of the impulse response is 3. So the output sequence having the length of 4 plus 3 minus 1. So the total length of the output sequence is 6. Now we have to substitute the value of k from 0 to 3 and we need to expand the summation. After expanding the summation, and we need to substitute the various values for small n. Initially put n equal to 0. Then you compute the y of 0. The resultant value of y of 0 is 1. Similarly, the n value can be varied from 1, 2, 3, 4 till 6. When you put n equal to 1, the resultant output sequence y of 1 equal to 3. Similarly, when you put n equal to 2, the resultant output sequence y of 2 equal to 6. Similarly, we have to put various values of n like n equal to 3, n equal to 4, n equal to 5. So when you put n equal to 3, the resultant sequence is 6. When you put n equal to 4, the output sequence is 4. Similarly, when you put n equal to 5, the resultant sequence equal to 1. And the final answer, consolidated answer of the output sequences y of n equal to 1, 3, 6, 6, 4, 1. The second method of computing linear convolution is graphical method. In the graphical method, the input sequences plotted, the magnitude of the input sequences plotted like shown in the first graph. And similarly, the magnitude of the impulse response is plotted shown in the third graph. Then the impulse response is time reversed. Here, as shown in figure, x of k is plotted. At position n equal to 0, the magnitude of the sample is 1. Similarly, at n equal to 1, the magnitude of the sample is 2. Similarly, at n equal to 2, the magnitude of the sample is 3. And at n equal to 3, the magnitude of the sample is 1. Then similar way, the h of k is plotted. At n equal to 0, the magnitude is 1. N equal to 1, magnitude is 1. And n equal to 2, magnitude is 1. Then h of k is time reversed. When it is time reversed, the samples what we will get is at n equal to 0, the sample value is 1, and at n equal to minus 1, the sample value is 1, and at n equal to minus 2, the sample value is 1. Then corresponding positions of the h of minus k and h of k are multiplied, which is nothing but y of 0. So y of 0, what we will get is 1. Then similarly, h of minus k is shifted by one position. After shifting, what we will get is at n equal to 1, we will get 1, n equal to 0, we will get 1, and at n equal to minus 1, we will get plus 1. And the corresponding positions of h of minus k plus 1 is multiplied with x of k. The resultant sequence is y of 1 equal to 3. Similarly, h of minus k is shifted by one more position. then resultant h of minus k plus 2 sequences at n equal to plus 2, the sample value is 1. Similarly, at n equal to plus 1, the sample value is 1. Similarly, at n equal to 0, the sample value is 1. Similarly, h of minus k plus 2 is multiplied with x of k, which will yield you y of 2. So y of 2 equal to plus 6. Similarly, the h of minus k is shifted by further one more position. Then corresponding sample values of h of minus k plus 3 is multiplied with x of k. The resultant sequence y of 3 equal to 6. Similarly, h of minus k is multiplied shifted by one more position, then corresponding samples of h of minus k plus 4 is multiplied with x of 4. Then resultant y of 4 sequence is plus 4. Similarly, h of minus k is further shifted by one more position. Then resultant sequence h of minus k plus 5 is multiplied with x of k. Then resultant output sequence y of 5 equal to 1. The third method of computing linear convolution is matrix method. This method generally used to cross-verify the answer which is obtained through tabular method and graphical method. In this way of computation, the input sequence x of n is plotted along vertically and x of n is plotted along horizontally. Then corresponding positions of the samples are multiplied. After the multiplication, the results are added diagonally, then that can be taken as the final output of the sequence y of n equal to 1, 3, 6, 6, 4, 1. Circular convolution is a periodic convolution operation where two sequences are multiplied, shifted, and summed with a finite length of n. The circular convolution can be computed in two ways. One is concentric circle method, second one is matrix multiplication method. Now we will see the example problem for the computation of circular convolution. Find the circular convolution of the given sequences x1 of n equal to 1, 2, 3 and x2 of n equal to 2, 1, 2. And for doing this problem using circular convolution method, we need to plot two concentric circles. One is inner circle and another one is outer circle. In the outer circles, we need to plot the first sequence in anti-clockwise direction, and in the inner circle we need to plot the second sequence in the clockwise direction, and we need to multiply the correspondingly positioned sample values, and we have to add all the sample values. Then we will obtain the value of y of 0 as 9. In similar way, in the second step, we need to fix the position of the outer circle, and we need to rotate the inner circle by one step in anti-clockwise direction, and we need to multiply the correspondingly positioned samples. Then we will get the value of y of 1. Here the value of y of 1 is 1 into 2 plus 2 into 1 plus 3 into 2 equal to 10. Similarly, in the third step, we need to rotate the inner circle by another step in anti-clockwise direction. Then we have to multiply the correspondingly positioned sample values. Then we will get y of 2 equal to 1 into 1 plus 2 into 2 plus 3 into 2. The final value is 11. So the total value of y of n equal to 9, 10, 11. The second method of computing circular convolution is matrix multiplication method. In this way, the output can be obtained by multiplying the periodically shifted version of the first sample into the second sample. Here, y of 0 can be obtained by multiplying 1 into 2 plus 3 into 1 plus 2 into 2, which yields the results of 9. Similarly, y of 1 can be obtained by multiplying 2 into 2 plus 1 into 1 plus 3 into 2, which yields the results of 11. Similarly, y of 2 can be obtained by multiplying and adding 3 into 2 plus 2 into 1 plus 1 into 2 equal to 10. Similarly, the final answer what we will get is 9, 10, 11, which is very similar to what we obtained in the last method. We will see the second example for the computation of circular convolution. The problem is find the circular convolution of x of n equal to 1, 2, 3, 4 and h of n equal to 1, minus 1, 1. Here the length of the x of n is 4 and the length of the h of n is 3. In order to perform the circular convolution, both the sequences must have equal length. In order to make both the sequences having equal length, we need to append one zero with the smaller sequence so that the modified sequence of h of n is 1, minus 1, 0. Then circular convolution can be performed either by using circle method or by using the tabular method. Then final result can be obtained as when n equal to 0, y of 0 equal to 0 and when n equal to 1, y of 1 equal to 5. Similarly, when n equal to 2, y of 2 equal to 2. Similarly, when n equal to 3, y of 3 equal to 3. In both the methods, circle method as well as in the matrix method, we will get the same answer only.